Welcome back. So in this video, I want to build a more advanced scenario. What we will do in this video is we are going to use the example that I showed in the video on using our scenario builder, and I will try to implement this very simple experiment using the, Python-based file functionality, you'd call it, or actually the actual library that is Alter Ego. So as you might remember, this is a framed ultimatum game, and I invite you to check out the other video on using the scenario builder. Now, I guess this video will be a little bit longer than the other videos, and this video is more for people who want to run even more advanced experiments, and also those people who might be interested in using Alter Ego with O-tree, because if you want to use Alter Ego with O-tree, you might need to have a more, profound understanding of the elements of Alter Ego. So that's what we're trying to do, and hopefully after watching this video and perhaps following along, you will be able to grasp the deeper meaning of life and also Alter Ego. First of all, let's continue with the essential concepts of Alter Ego. So in principle, Alter Ego gives you two things. The first thing is a coherent, persistent structure for grouping together multiple threads, if you want that. And the second thing is the opportunity to use dynamic prompts. Both of these crucial features are essential for experiments with large language models. So let's talk about the first one, because we have already talked quite a lot about templating in the other videos. So the structure provided by Alter Ego is basically one in which one or multiple threads can be combined in a conversation, and that conversation aggregates these threads and ultimately also provides a shared persistence context for these threads. And we will talk about what that means in a second. And what you can then do using our provided methodologies is you can automatically have a treatment assigned to the conversation. And obviously, the fact that the treatment assignment is persistent is a crucial feature for most experiments, at least between subject experiments. So that is basically the structure of Alter Ego. The nice thing about Alter Ego is that if you combine this with a templating engine that is sufficiently powerful, such as Ginger 2 in our case, then you can create a situation where within the structure, prompts can actually vary depending on the treatment, on other threads values, on the particular given threads values, and so on and so forth. So let's actually try to implement a very simple framed ultimatum game that we saw earlier. And let's see whether we can do that without many changes. So I just opened my editor, Genie, and let me now open a new file, and let's call it ultimatum.py. There it is. And we will start fresh and new, and we will try to build this framed ultimatum game, at least how I would implement it. And this exercise will also tell you perhaps a little bit about how the builder actually works. And if you want to check out the source code of the builder scenario, of the build scenario as it's called, then you can check out our GitHub repository. You can go to build.py, and there you can see how it works. As you might imagine, the code there is quite general. Okay, but let's now do it for the simple framed ultimatum game. So first of all, what I will do is I will import the agents that we will need. Let's actually do that. From Alter Ego agents, import CLI thread for now. Yeah, and then we will use a facility that automatically assigns treatments to conversations. You see, that's the experiment facility. So let's also import that one. Let's import the actual facility that enables conversations to work. And I guess now we can get started. So in principle, a scenario, as we call it, implements two functions. The first function is called run, and it gets the argument times, and it has the default value 1. We will implement this in a second. And the second function that we get, or that we need to implement in a scenario, at least for it to be very useful, is called export. And that will actually export the data of a particular thread, and this here will return a dictionary. Now, the run function actually doesn't return anything. So in Python, if we used typing annotations, we could say times is an integer, and this function doesn't return anything. A thread is basically just a thread. So here we could do this, and we would say this actually returns a dictionary at the end. It can also return a list of dictionaries, as we will see later on. Anyways, that is of course optional, as type annotations are not enforced in Python. So now, of course, we need to think about the structure of our actual experiment. And as we discussed previously, our experiment has three treatments. So let's do this. By the way, treatments can basically be any kind of Python object. So you're completely free to use a class, to use a dictionary, to even use a list or just an integer. You can do whatever you want. And you will actually see one instance where there is a difference between what we need to do now and what you can do with the builder, but this will be easy to fix. Anyways, let's define our treatments. So first of all, I will just use dictionaries, but there's no particular reason to use those. It's just, what is useful most of the time. So we have the treatment give. It has the name give, and it has a certain proposer instructions. Let me just copy that out from another window where I prepared this. And let's do the very same thing also for take and for split. Let me also copy that. So basically here, you can go back to the video on the builder, but what is going on here is quite straightforward, because we basically have one variable that varies between the treatments, which is the proposer instruction, and each treatment also has an associated name with it. As you might imagine, both the name and the proposer instruction will be used later on in our prompts. And of course, here at this position, you could also add further variables, or you could do all kinds of crazy designs. But what we're going to do, as I promised, is we are going to take the example of the builder, and we will try to do it without the builder. We will try to do it manually using the alter ego library. So let's continue on. I will now add the system prompt, and that here as well, I just basically copied over from the builder. So let me copy this out. Here it is. Yes. Okay. So now I didn't change anything here. This is just from the builder and the builder video. And I will do this very same thing for the user prompt. So let me also copy that in. Here it is. And I think what we need to talk about for a second are these variables. Okay, so in the builder, some variables were predefined, and everything was worked well. And some variables are predefined, and they are passed on to the templating engine. However, you will very quickly see that the builder has a certain affordance that is made to you to make it easier to refer to treatment-based variations. In fact, variables like round and I, they are not defined by alter ego. They are only an affordance by the builder. We need to define those manually. So just keep that in mind. Okay. So now we can actually continue on with our pass function. And what we will always do in our, in our run function, actually. And what we will always do in our run function is we will always start out with creating an experiment. And an experiment basically is a very simple object that is able to randomly assign treatments to the conversation. So what we will do now is we can say, my experiment is an experiment of the treatment give, the treatment take, and the treatment split. Okay? So basically you can list all the treatments and they can be assigned later on to conversations. The second thing we will pretty much always do is we will, run through this experiment, times, you could say. So in other words, if we want to run it 5 times, it should run for 5 times. If we want to run it only once, we will only run it once. So what we will always have pretty much is a for loop, which says for run in range times. And here now the complicated stuff happens. Let's start out with a very naive implementation and let's see what happens. So let's say we are now faced with a new run of the experiment, which means we will have to create the proposer, the responder, the conversation. We have to assign a treatment to the conversation. And then we have to submit the prompts, get a response, and filter the response. Okay? That's basically it. So to create a proposer, we can simply say, proposer equals CLI thread. Note that we imported the CLI thread, up above. And we can say the very same thing for the responder. And now we have 2 CLI threads. We will now group them together in a conversation, which can be done as follows. The syntax is similar to the experiment. So we will say we have the proposer and the responder. And by the way, make sure, if that is relevant for your particular experiment, to group them together, but in the correct order, because the order can matter if you iterate through the threads, for example. Okay, so now we have the conversation, and now the experiment facility actually provides a method to link a treatment to the conversation. And that is one of the things that we give you with alter ego. What we can do is you can say my experiment link and then convo. And this randomly chooses one of these 3 treatments and just puts it into the conversation. One thing I should perhaps mention at this point, is that every time we replicate the experiment, new CLI threads will be created, which is as expected. Okay? So now we have a treatment assigned to our conversation. And now what we can try, first of all, is to just do convo all system and then system prompt. Now, what does this do? This may seem a little bit strange or complicated. Now, what you can always do, but what we will not do, is you can always do something like proposer, system, and then you could send them the prompt. Okay? And you could also do the very same thing for the responder. But this notation up here in this line basically does both of these things for you automatically. And you can see that it does them automatically because it uses this all facility. So this is sort of a shorthand, you could say, which uses a special programming technique, a certain pattern, but we don't need to get into that. And this pattern allows you to basically do many things at once using just one command. So we will delete this here. By the way, another way to write what I just deleted would be the following. You can also iterate through a conversation. What you could do is you could say for thread in convo, thread system prompt. And that would also have the very same effect. In fact, convo.all.system is actually implemented in exactly this way. Okay? So we can delete this for now because this shorthand allows you to do it all at once for everyone in the conversation. Now, let's try naively whether this works. Hint, it won't. But to run this scenario, you now need to type ego run ultimatum. And ego run ultimatum will load this very file here and will execute the run function. And if you pass in the n argument here, for example, like this, then times would be set to 42. But we will not do that for now. The default is 1, which is fine for us. And you will see that this will now fail. So let it fail. And there it is. There's a big error, which basically says a Ginger2 exception, I is undefined. Now, we only submitted the system prompt so far, so let's go to that. And here we see the culprit. So the problem is that our system prompt relates or refers to this variable I, but as I said, that is only an affordance made by the builder. It's not an inbuilt functionality. So to get an I, what we could do is we could associate an I with every thread. Let's do that. We could say, and this, by the way, is a general syntax that always works and which follows certain Python principles, certain Python built-in classes that also have this. What you can always do is you can say you have a CLI thread or a GPT thread or whatever kind of thread you have, and you can say, you have a certain variable, and this gets a certain value. So the proposer has I equal to 1, and the responder has I equal to 2. And that makes the variable I, or actually the attribute I, to be very precise, available in prompts. And that is a very important feature. So let us save this. And if we run again, we actually do see that the system instructions are correctly put in. So you now see the proposer starts out and the responder follows along. And you see that apparently the if statement in our prompt was correctly executed, meaning the proposer saw this and the responder saw that. And that is all thanks to this extra attribute that we put in. That is very useful. Now, let us try to continue on, and let's think about what we need to do now. So in general, what we would like to do now is something like this. We would like to say proposer, submit the user prompt, and then the proposer should put in, their number, basically how much they want to keep. And we talked about this in the video on the builder, so please go back to that if you don't know what I'm talking about. And then we want to extract it using JSON. Okay. So to do that, what we need to do, or what we should do at least, although there are different libraries that also allow for this, we should import JSON. So this imports the JSON module. And what we can do here, we don't just submit the user prompt, but actually what we do is we say, the current offer was JSON.loads. And then what is returned by submit is actually the raw response by the thread. So in other words, proposer.submit sends this message, user prompt, correctly templated, to the proposer. The proposer responds in a certain way, and then this response is put in to JSON.loads, which sort of, extracts the data from this JSON format. Okay? Now, if we do this, once again, this will fail, and let me show you how. So now we get a similar error as before, round is undefined. That's right, because at the very beginning of our user prompt, we say this is round. And this placeholder, again, will invoke the templating engine, so we need to sort of specify a round. So what we could do here is we could say round equals 1, because for now we just have one round, okay? We can deal with rounds later on if you want. So if we try to run it again, this error is eliminated, but another error occurs, which is called, which sort of calls our attention to the fact that proposer instruction is undefined. Now that is actually a little bit more difficult to solve, but it's also very simple to solve, I'm happy to say. This is the central affordance made by the builder. So if you have multiple values of a variable, varying by treatment in our builder, then the variable itself will be directly passed into the template if you use the builder. That's to make it a little bit easier and not to type treatment all the time. But of course, if you want to build a custom scenario, as we are doing right here, we cannot do that for you, okay? Because a treatment can have a very complicated structure. As I said, it can basically have any Python object whatsoever. In other words, we don't necessarily know what you're doing. And for that reason, we need to change the prompt, which is the only time we need to do it, actually, in this tutorial. So you'll see the builder is very close to reality, but there is one aspect where it gives you something that, a more complex experiment does not automatically give you, and that is with respect to treatment varying variables. What an experiment does is it assigns a treatment, and you can access the currently assigned treatment by doing treatment dot, and then you're in the treatment object. And as we discussed in the very beginning, our treatment objects here is one of these three. So they should have a very similar structure, which of course could be, also a good thing for you to remember, because you might want to use something like data classes or stuff like that. But in any case, here we are just using a dictionary. But what we need to do is we basically need to access this here item in these dictionaries. And to do that, as I said, we need to use this treatment attribute, which the experiment automatically assigns to the conversation. So what we need to do, instead of saying just proposer instruction, we need to say treatment.proposer instruction. And that will lead us to the correct value for the treatment instruction given the current treatment. Okay, so let's try. Let's see whether this error is actually eliminated. And yes, it is. For now, let me actually stop this script and let's not continue because we need to implement some more stuff here. Okay, so as I said, this is one of the things that you need to remember. You need to make sure to access the correct object if you build the scenario yourself. And that can obviously be quite important if you use alter ego with O-tree. For example, in our ego human example experiment, we used, this sort of, trick, this sort of gimmick. What we also need to do is we need to manually put in the actual choice that was made by the subject. So again, because you can basically do everything you want and there's a lot of freedom involved with building your scenario manually, we cannot automatically extract the choice made by the large language model. Instead, you do it yourself, and we give you some helper functions for that as well. But what you need to do after that is you need to say proposer.choices, which, by the way, is one of the built-in things, the built-in attributes that are attached to every thread in alter ego. So this always exists. And here you would say proposer.choices, append, and then the offer. And that would add the offer that was just made to the choices of the proposer. And now we could actually send over the offer to the, other participant, to the responder. And that will work because within this conversation, as I said, it's a shared persistent context. Any thread can access other threads. And that is exactly what we use in our prompt, because in our prompt, as you might recall from the other video, we do this other.choices, and then we access the keep attribute of the JSON object that was returned by the proposer. So in other words, to get this, we sort of need to fill out the choices of the other player, which we just did because we put it onto the proposer. And then, I guess, this will work. So basically, what we can do now is we can say acceptance equals responder.submit, the user prompt, because the user prompt entails values for both players in this game. And this would actually submit the user prompt with the correct value to, the responder. And let's see how this works. So let's run again. let's say we keep $9.99. And now you see the proposer decided to take $9.99, leaving you with this expression right here, which is due to floating point issues in Python. This has nothing to do with alter ego. There are ways around it, but we could talk about them in the comments. Please comment down below if you don't know how to fix this. But this is quite straightforward to fix. I guess if you're building your own scenario, you know how to fix this. For example, using a filter in Jinja 2, or you could also use you can also transform stuff and so on. So don't worry about it for now. You see that the responder is able to access the other person's value, okay? They are able to access the other person's keep value in what they returned. And now we could respond with accept, and this will actually conclude the experiment. Now, this is, of course, is not so fruitful, but what we actually want is we want to sort of find out whether the person accepted or rejected the offer, as in the builder. So what we will do now is we will use a utility that is brought along with alter ego, which is called exclusive response. And that is also one of the filters available in the builder. So basically what we will do is we can say from alter ego utils import exclusive response. And that is a very simple function, which we can basically wrap around what they sort of responded. And we have two tokens that are allowed here. The first one is accept, and the second one is reject. And this basically checks which one of these tokens sort of was returned. Okay. Yeah, and then here too, what we will do is we will say responder choices append the acceptance value. Okay. So this works. However, finally, we need to actually save this run. So to save this run, what we can do is we can save the whole conversation by basically doing convo all save, which would already save it. However, I always recommend to use the experiment facility for this, because we can save it automatically into a certain subdirectory, which then is easily accessed later on if you, for example, if you want to export the data. So what we do, we save it into the subdirectory myexperiment.id, and then at the very end, after we have run the experiment, times, we can say experiment is ready or something. Okay. All right. So let's actually run this. This will basically work, although it's a little bit unsafe, and I will show you why in a second. The thing is, to use this most usefully, you should always implement this export function. And the export function, as I said, can return a dictionary or a list of dictionaries. And what we will do in this particular instance is for each thread, what do we want to, return? Well, let's suppose at some point we add further rounds to our experiment. Then our choices list for each thread will actually tend to grow over time. And of course, we want to return every choice that the agent made. So what we can do is we can basically say the following. So let's actually return a list of dictionaries. And what we can say here is we can say for choice in thread.choices. And what do we need to know? Well, first of all, we might want to know the I so that we can distinguish these roles. And then also the actual choice, obviously. So what we want to return actually is a list of dicts. So we can say the return value is basically an empty list in the beginning, and then this will be filled. Finally, we return this. And what we say here is we say retval append, and here we append a dictionary. And inside of this dictionary, what do we need? Well, we need the I, which is just thread.I. We also want to have perhaps the treatment. So here we would say thread.treatment treatment and then the treatment's name. Of course, name is a key in our treatment, in any particular treatment. So we will get this, this, or this. And what else do we want? Well, we want the actual choice. So what we can say is the round, perhaps. Round. And here we will need to find a solution, actually. Let's say round. And we will say, you know, the choice was just choice. Okay, so that's the easy part. But let's actually say for round and choice in enumerate, comma 1. And what this does is that this iterates alongside thread choices, but it also carries along a certain number which is increased. Okay, as we go through the choices, we sort of, you know, increase this index, we increase the round, so we can sort of, you know, map back in which round which choice was actually taken. So I haven't tried this particular code before, but let's see whether it works. So let's run our experiment. And yeah, let's see what happens. So first of all, we are now in the split treatment. So let's say we keep $5.50. Here we get the correct calculation. Very good. And here we say, I decide to accept. So note that we do not exactly use this or this, but because exclusive response by default is case insensitive, this will also be fine. Because accept is still present, just not in this capitalization. Let's do this. Now we get the message experiment 5F and so on is ready. And now let's take this and we should be able, and again, I haven't tried this, so please excuse any errors. So what we can do now is we can say ego data ultimatum. So I have tried some other code, but not this particular code, with this ID. And yes, it seems to have worked actually. So let us open this data in LibreOffice. And for that to work, let's actually redirect this to data.csv. And let me open this in LibreOffice. So as you can see here, this has worked correctly. Some columns are included by default. These are the experiment column and the thread column. The other columns, as you might remember, were put in by ourselves. So we have the treatment, which was correctly extracted. We have the round. We have the I, which sort of tells us this here was the proposer and this was the responder. And here we have the actual choice. Note how the exclusive response filter filtered out the accept, and we sort of ignore all of the other stuff. Okay, so this has worked well, and we can now continue on by extending our program. So now that we have inspected that the data export and the experiment themselves work fine, we can now try to see what happens if an error occurs. So for example, let's suppose we start our experiment again. And now let's say our response is like complete nonsense. Okay, let me just, you know, randomly type in something. The problem is that JSON loads up here, JSON.loads will still be invoked, but only with a garbage message. Now in that case, we would like to sort of mark this particular conversation as invalid or as broken. And for that, we also have a facility. But of course, we need to sort of catch this error. What you can do in the easiest of circumstances, if you are certain that your code is correct, what you can do is you can say, try all of this. And then you could say, except exception SE, you could say, convo all tainted equals true. And convo all tainted is a facility to set sort of a certain status of the conversation, which starts out as being the good status, meaning tainted equals false, to set it to true so that you can know that a conversation did not work out. Okay? Finally, we still want to save all of the data, of course. but this gives you an opportunity to set tainted to a certain value. And as I said, tainted start out as false. So let's actually put in tainted here as well. Here we could say thread.tainted. Now, if we export the previous value, the previous data, and if we open it in LibreOffice, then you will notice that tainted was false, as expected, because we put in everything as would be, again, expected. But if we try to redo our experiment, and if we, again, enter some garbage, then you see, actually, it does not abort. We would continue on with the next run, if there were a next run. But as you will see, if you inspect the data, that this conversation was set to tainted. Okay, there was something I didn't consider, which is that if we start out with an invalid response, of course, the choices will never be actually set. So in other words, what we could do is we could actually check here whether the thread was tainted. So in other words, what we should do in the export function is we could say, if thread tainted, and in that case, we only return tainted true. And that would actually lead to a valid response by the data export. Yes, and here you can see now that this column is always true. If we had had some valid responses as well, they would have these extra columns that we have here. But the reason that I need to put this in here is because the thread.choices are never set if the thread starts out with an invalid response. Because once an invalid response is encountered in this position, we will go straight to this place here, and this will never be invoked. So that is why we can put in a check like that. And if we run our experiment now multiple times, so let's say run n2, let's say we start out with garbage, and then in the next round we sort of behave actually very well. And now if we export the data, then you will see that the first run has tainted equal to true, and you see that some columns are missing because we just do not have choices here, and the others have tainted equal to false, and those just proceeded normally. So that is how you can build a custom export for your scenario, and you can access all of the parameters that are built into the threads as you did. Okay, so let us now continue on. So I would always try to use some sort of try-except methodology here, but I personally like to sort of be a little bit more precise here with these exceptions that can be caught. But if you're really certain that everything should work, then you can just use exception SE as usual in Python. Now, let us try to see what happens if you want to run multiple rounds. Of course, if you want to run multiple rounds, we should remove that. But where should the round actually be? Well, should the for loop that sort of creates the rounds, should it be up here? I don't think so, because that would create two new threads. Should it be here, like right before the conversation? No, I also don't think it should be there, because then a new conversation would be created. This doesn't have much of an effect in this particular instance, but it's just not necessary. Should the for loop be here? No, that would be quite wrong, because then a new treatment would actually be assigned. So that we should not do. Should it be here? No, would also not be sensible, because fundamentally, the system prompt will stay the same. As in our experiment, the treatment is assigned and the system prompt also stays the same. Actually, threads will raise an error if you try to change the system prompt over time because of this coherence that we impose on this structure. So in other words, the only place where the round can begin is basically in this here piece of code. So what we should do is we should sort of indent this, and what we can say is for round in range, and let's say we run for 4 rounds. So the range will go from 1 to 3 in this particular instance. And here we can say, as you might imagine, convo.allRound, and that sets the round number in every thread in the conversation. And now our game will actually run for 3 rounds. And the variable round, which we refer to up here in our template, should be set accordingly, and the same threads should stay together. So let's see whether this works as expected. So let's run this only once for now. So now we see this is round 1. And let's note these agents here, FD and 10. So let's see, keep 1, and we accept. And then we see this is round 2, and you see FD is still the responder. And now let's say we keep 0. Now again, the responder is 10, meaning has the ID 10, 4, and so on. And now finally, we say keep 10, and we reject. Now, if we export the data, we should now get 3 rows of CSV and 1 header row for each agent, I mean. So here it is. So here you see for 2 agents, and each agent would have played 3 rounds. So this all worked as expected. As you see, there's a tremendous amount of flexibility in what you can do. For example, if you did actually want to have some sort of stranger matching, you could call it, you could actually create a new responder, and then you would actually put the round up here somewhere, and then you would actually do it something like this. I didn't exactly check this, but this should basically work, perhaps with some minor changes. So that is how you can actually build your own scenario and how you can basically do whatever you want. Now, this is all fine and good, but typically you will not want to sort of do this with the CLI thread. The CLI thread is extremely useful for, testing your experiments and seeing whether the templating worked and so on. And I have to give big credit, by the way, to the library called Colorama, which is just a very nice and beautiful library to sort of make it visually easy to discern what's going on in the terminal. So big props to them, and of course also to Ginger too, for being like really great libraries. But typically you will want to use a GPT thread or like another kind of language model. And that is also quite simple to do. Let's just import the GPT thread. And let's change our design, you could say. Let's do it like this. And what we need to say in the GPT thread is we need to say model and temperature. So let's just take these values. You could also take others. This is, of course, for you to experiment with. So now if we run our experiment, so there was actually an error in the code, which led to the API sort of complaining, which is that the temperature, of course, must not be a string, but it must actually be a floating point number. Sorry about that. So let's try to run our ultimatum game again. And here we get all the data. So in this particular case, we had just 1 run, of course. We had 3 rounds, and we had the split treatment. GPT proposed to keep 5, and it always accepted. So this could be, 1 result basically. So this shows you how you can build your own scenario, and you can do all kinds of complicated things within your experiment. Of course, you should always try to keep it simple, but we provide a documentation for you to look at what kind of classes and methods are exposed by Alter Ego. I hope that this tutorial gave you some insight into how to actually use Alter Ego for your own more sophisticated experiments. In general, I would always recommend that you try the builder first, and later on, you can try to build your own experiment, your own scenario, using the classes that we provide. Never forget this here image. And I thank you so much for your attention. Have a good day and enjoy your evening. Goodbye.